Here we have a problem. The graph of a function is shown. This is f of x. The question is to evaluate the integral from 0 to 2 f of x dx. We know we want to define integral from a to b of a continuous function is visually shown as, if a function is continuous from a to b, then this integral is represented by area enclosed between the curve and the x-axis from a to b. Okay, now they are asking in part A, integral from 0 to 2 of the function. 0 is here, 2 is here, so integral from 0 to 2. So area under the curve, which is the red line, from 0 to 2 enclosed between x-axis. That is what we need to find. Okay, now this shape is a trapezoid. One method of doing a trapezoid area is half sum of the bases times height. In this case, there are two bases are 1 and 3 times height is 2. So that's going to be half times 4 times 2. The answer is 4. So you can do it like this. Sometimes what happens is students don't remember the trapezoidal area formula. So you can also say I need to find this area, right? Even if I find the area of the triangle, which is half base times height. So half base is 2 times height is 2 plus area of the rectangle, which is 2 times 1 because length times width. So 2 times 1. This is 2 plus 2. The answer for the first integral is 4. So you can either use the trapezoid area formula or divide the shape into triangle and a rectangle and find the area. Both works fine. Let's work on part B. It is from 5 to 7 integral of the function. 5 is somewhere here and 6 and this is 7. So from 5 to 7 the graph goes below x-axis. So area enclosed between the graph and x-axis from 5 to 7 is given by this triangle. Area of this triangle would be half base times height. Base is 2 units, height is 3. So half 2 times 3, the answer would be 3. But because this area is below x-axis, you're going to answer the integral as a negative number. Please remember, whenever your shape is below x-axis, that becomes net area. So that has to become up as a negative area. Let's work on the C, 0 to 5, integral of f of x. 0 is here, 5 is here. So we need to find area from 0 to 5. Basically, all this area has to be found. This shape, geometrically, we do not know. So I'm going to divide this from 0 to 2, from 2 to 3, and from 3 to 5. Okay. So from 0 to 2, we've already figured it out. We can say this integral is from 0 to 2 f of x dx plus from 2 to 3 f of x dx plus from 3 to 5 f of x dx. From 0 to 2 we've already figured out, so I'm going to just put it 4. It's that area of the trapezoid. From 2 to 3, let's figure that out. That's a rectangle here. The width of the rectangle is 1 and the length is 3. That's going to be 3 times 1 plus, lastly, we have this triangle from 3 to 5. Okay, that is the base of this is 2 units and the height of this is 3 units. So basically that's going to be half 2 times 3. That's going to be 3. So your answer is 4 times 3 times 3. That is going to be 10 units of the area. So please remember, basically it's the area enclosed between the curve and the x-axis. If the area goes below x-axis, then we have to find it as a negative number.